Right. Welcome back to my YouTube channel. This is Mr. Hyper taking you through integration, and we are going to now look at integration using the partial fractions. So we shall be involving partial fractions, and to bring to your attention, I want you to know that there are three types of partial fractions, and these are always depending on the nature of the denominator. And those three involve linear. We have linear partial fractions. We have quadratic, and then we have repeated. So good, linear, quadratic, and repeated. And without wasting any time, we shall begin with the linear factors, integration involving partial fractions, but under linear factors. Before I take you into the details, I want you to first know that when we talk about linear factors, when you talk about linear factors, we are trying to mean factors like x minus 1, x plus 2, something like very linear. There is no quadratic expressions. They are not repeated, so they are just linear. But when we say quadratic expressions or quadratic factors, that is where we have something like x squared plus 2. When you have quadratic factors that can't be easily factorized, so you can't easily factorize this. We have got something like 2x squared minus x plus 1. We've got something like 2x plus 3, x squared plus 3. So these are what we call repeated, rather quadratic. Then for the case of repeated functions, this is why you have something like x plus 1 squared. So we shall see how we work on this, how we work on something like when it is cubed, etc. So we are going to look at how best we can integrate these depending on the nature of the function given. So let's begin with the integration involving partial fractions and linear factors. So let's begin with linear factors. For the case of linear factors, I want you to know that maybe the note that I can make is that each linear factor which takes the form ax plus b in the denominator has a corresponding partial fraction all right, maybe the form C out of ax plus b, where a, b, and c are all constants. So let's look at examples under these linear factors. Let's look at examples, and then we see how best we can do them.
Now I want to see how we modify this experiment we have already seen. That we can work out.
So basically, I'm going to say express the following in partial fractions. Hence, integrate each expression with respect to x. So here, it is going to be easy for us. I've set a general question, but we have x minus 1 over x plus 1, x minus 2. Part B, we shall have 1 over x cubed minus 9x, and C, we shall have x plus 1 over x minus 1 into 3x squared plus 7x plus 2. Then 4, we have x squared minus 1 plus 1 over x squared minus 1 then x plus 2. That was number 1. So number 2, evaluate integral from 1 to 3 of x squared plus 1 over x cubed plus 4x squared plus 3x dx. So we're going to look at these examples. I'm going to do some, and then I leave you with some to do. So I will do some, then others you are going to practice on your own. Well, let's go for solution, and I'm going to begin with number 1. Very interesting. So solution, number 1, part A. I'm going to let that expression which they have given me, which is x minus 1 over x plus 1 times x minus 2, I'm going to let it to be equal to, we say that each partial fraction, or rather each factor in the denominator corresponds to its own partial fraction. So we shall say A over x plus 1, that is the first one, plus B over x minus 2. So that is what we are having. So for us to get an expression expressed in the partial fractions, we are going to work on this by taking the LCM, and then we get the values of A and B. So to take the LCM here, since we are starting, let me detail the explanation. It means that x minus 1 over x plus 1 plus into, x minus 2 is going to be equal to LCM, that is A x minus 2 plus B into x plus 1 over, the LCM is x plus 1 and x minus 2. So the moment these ones, of course, cancel, so we shall have x minus 1 equivalent to A into x minus 2 times, rather plus, this is a plus B into x plus 1. There are 2 ways of doing this question. Actually, from here, there are 2 different ways of doing it, whereby by inspection you can get the value of A and B. Else one can use just factorization. Rather, you can expand. One can expand, and as you expand, you will collect like terms. Then you equate the coefficients of x and the constants. So the issue here is to find the values of the constants A and B. So we can find A by substituting X as -1 so that this B goes. So the first idea is putting X as -1. When you put X as -1, this side it will be -2 is going to be equaling to A into -1 minus 2, which is -3. So that your A is equals to 2 out of 3. If I'm to get B, I can put A as 2 so that A goes and I get B. So putting X as 2, here it will be 2 minus 1, which is 1. And 1 is going to be equal to 2 minus, all of this is 0. So this is a 3B. So you're going to get B as a third. Alternatively, if we see that you have time, you can try this. X minus 1 is equals to expand it. It is going to be X minus twice A plus BX, then plus B. You're going to correct like terms here, those of X, so it will be A plus B into X, then plus B minus 2A. For this case, now you can equate, this is an alternative. You can equate coefficients. So for X, if you equate the coefficients for X, you have to tell us that you've equated. So when you equate the coefficients for X, this is going to be 1 this side, or the coefficient of X is 1, but this side it is A plus B. That is your first equation. Another equation, you equate the constants. The constant this side, we have -1 is equals to the constants here are B minus twice A. By solving these two equations simultaneously, try it, you'll get the values of A and B. How? You can multiply, you can add the two equations. You can subtract these two equations. When you subtract, you have 1 minus -1. So this side you have 2 is equals to B will go, so you have A minus 2A, which will be 3A. And this one can give you a value of A as 2/3. Then you substitute this value of A in any of the equations, you find yourself with the same value of B. So now it implies that it would imply that our X minus 1 over X plus 1, X minus 2 is equals to value of A. The value of A is 2/3, so that's the same as 2/3 out of X plus 1. You write it, X plus 1, then plus B. B was a third, all right? B is a third. So allow me write a third out of X minus 2. This is equally, we can say 2 over 3 X plus 1 plus 1 over 3 X minus 2. Interesting. So now it implies that the integral, because they say that hence we integrate the function, so the integral of X minus 1 over X plus 1 times X minus 2 dx, that is with respect to X, is going to be equal to the integral of 2/3 of X plus 1 dx plus integral of 1/3 of X minus 2 dx, which is the same as someone who has factorized out. We can factorize out a 2/3, so 2/3 integral of 1 over X plus 1 dx plus 1/3 integral of 1 over X minus 2 dx. In a case where you find that the derivative of the denominator is equal to the numerator, It means that the integral of this is the ln of this. So we shall have 2/3 ln x plus 1, then plus 1/3 ln x minus 2, plus a constant of integration. All right, but we all know that ln, that is continuing. We all know that ln has got the properties similar to those of logarithm. All right, so allow me say, since I'm adding them here, all right, since I'm adding them, which means that it's similar. The way you have maybe log 2 log 2 is the same as log 2 squared. So the same. It means that I can put out 1/3. Then I say ln x plus 1, of course, squared, because these two, the way you treat log, the way you treat ln, only that this is natural logarithm, but this 2 comes here, so we have 1/3 out, all right? Then I can say 1/3 ln x plus 1 squared, then times x minus 2, then plus a constant of integration. Now, this one pretty mean that you're adding numbers of the same base ln, and then you can multiply. So that is how the solution of that question will be. That is how the solution of that question is going to be. Then part B of number 1. Part B of number 1, we are having 1 over x cubed minus 9x. Well, allow me to say that this is the same as 1 over factorize out x, so it is going to be x squared minus 9. Okay, which is the same as 1 over x into this x squared minus 9 is the difference of 2 squares, because 9 is the same as 3 squared, so it is x squared minus 3 squared, which is x, all right, minus 3 times x plus 3. I've done this simply because this is the difference of 2 squares. Here is a 3 square. So allow me say, I'm letting what I've got, 1 over x into x minus 3 into x plus 3. I'm letting it to be equal to a, all right, out of x, each partial fraction, plus b out of x minus 3, then plus c out of x plus 3. Taking the LCM, of course, it's going to be 1 over x minus 3, x plus 3 is equals to a into x minus 3, x plus 3, plus b into x, which is at the same time x plus 3, plus c into x, then into x minus 3. Everything over x minus 3, x plus 3. Like how we normally take LCM, how we normally take the LCM in the how we normally take the LCM in other algebra questions. Getting the whole this, you divide it by this, then you multiply up there. So you can realize that these ones cancel, so we shall have 1 is equals to a into x minus 3 into x plus 3, plus b into x plus 3, plus c into x minus 3. Here, the main important thing is solving now for values of A, B, and C. If we want A, what are we going to substitute? If we want A, we shall substitute, because when you put here a 0, the whole of this will go. If you put here a 0, the whole of this will go. So let's put x as 0. When you put x as 0, yeah, it will be 0 minus 3, 0 plus 3. So it will be 1 this side is equals to negative 9a, where this is negative 3, positive 3. So when you multiply, they make 9. And this one gives you your a, the value of a as negative 1 over 9. Then if I want b, it means I'll put here negative 3. Sorry, I'll put here 3 and here a 3, so that I keep with b only. But as I told you, someone can as well expand, and then you factorize. Okay, but by inspecting and you see what you can easily eliminate, you can easily get the values of A, B, and C. So let's put the value of x also as 3, so that we get b. So this side it will keep constant 1, and for the case of b, if you put here 3, here it will be 6, because it will be 3 plus 3, that is 6 times 3, that is 18. So we have 18b, implying that the value of b is 1 over 18 after dividing by 18 either side. So if we are to get c, we shall put x as what? If you want c, we shall put negative 3, so that this one go and this one go. So when we put negative 3, this side we shall keep with 1 over, so rather 1 is equals to, when you put here negative 3, it will be, when you put 3, put negative 3, so it will be negative 9. Negative 9 times, no, it will be negative 6 times 3, that is negative 9. Is it? Sorry. It is going to be, here we put negative 3, so this is negative 3. Oh, it is going to be 18, sorry. So you're going to get your C as 1 over 18, implying that our partial fraction is going to be x cubed minus 9x is going to be a, the value of a we've got here, negative 1 over 9. So it's going to be negative 1 over 9x, all right? Then plus b, which is 1 over 18 into x minus 3, plus c, which is 1 over 18 into x plus 3. So that is what we're having as a partial fraction, and integrating it isn't too much deal. Integrating this isn't a very big deal. How do we go about it? How do we go about it? So we are going to have, it implies that the integral of 1 over x cubed minus 9x dx is going to be equal to the integral of negative 1 over 9x dx plus the integral of 1 over 18 x minus 3 dx plus the integral of 1 over 18 x plus 3 dx. So this is, if you factorize out negative 1 over 9, it's going to be negative 1 over 9 integral of 1 over x dx plus 1 over 18 integral 1 over x minus 3 dx plus 1 over 18 still integral 1 over x plus 3 dx. This is negative 1/9. When you integrate 1/x, the fact that when the derivative of this is 1, this is going to be ln x plus 1/18 ln x minus 3 plus 1/18 ln x plus 3. You need to understand, of course, plus a constant c. You need to understand to what extent or in which cases do we put ln. It's when you find that when you find the derivative of the denominator, it is equal to the derivative of the numerator. All right. So here, what we are going to do here, okay, what we are going to do, I can factorize out 1/18. If I factorize out 1/18, here I will have, because here it is 1/9, so I will have -2 ln x. So that when you cancel it, remains 1/9. So that is it. Then plus ln x minus 3, then plus ln x plus 3, everything plus a constant of integration. So this is 1/18. I told you that ln behaves as logarithm. So I can say ln, into, let me use this bracket now, ln into, of course, it will be x power -2. So x power -2, when it moves down, it becomes x squared. So I will have these ones multiplied because here I'm adding, right? So it's the same as x minus 3 times x plus 3. Then, of course, plus a constant of integration. And that's the answer. I want you to get me right here. It was -2 ln x. This is the same as ln x power -2. So I have x power -2. In other words, the whole thing would become 1/18, right? Ln x power -2 plus ln x minus 3 plus ln x plus 3. So here, this is the same as, of course, 1 ln inside here. The inside thing will be ln, okay? So this x power -2, when you put it down, it becomes x squared. But the fact that here I'm adding, it's the same way as multiplying these numbers. So that is what we are having for that. And I'm going to do allow me to do another part of that question. And let me do part 3 or 4. I need one of those. I need one of those. Because for the part 3, let me give you a trick so that I'm going to do part 3, okay? Let me do part 3. Then part 5 will give you a logic and you do it. So part 3 of this question, is, they gave me twice x plus 1 out of x minus 1, then 3x squared plus 7x, then plus 2. So what do I do here? What do I need to do here? Now, what I do here, I just look at this, I just look at this, I just look at this. Of course, if this one can have factors, then you first factorize it. So let me say that 3x squared plus 7x plus 2 is the same as, now I need to first work on those factors here. The factors which when multiplied gives you 6, and when added gives you 7, that is 6 and 1. So I will say 3x squared plus 6x plus x plus 2. So you can factor out 3x into x plus 2, then plus 1 into x plus 2. So the factors are 3x plus 1 and x plus 2. All right. So it would mean that my 2x plus 1 over x minus 1 into 3x squared plus 7x plus 2 will be the same as twice x plus 1 over x minus 1. The 3x squared is going to give me x plus 2 and 3x plus 1. So I will let that 2x plus 1 over, okay, over x minus 1, then x plus 2, then 3x plus 1. It's going to be a out of x minus 1, x plus 2, sorry, plus b over x plus 2, then plus c over 3x plus 1. All right, so this is, of course, after taking the LCM, x plus 1 is going to be, after taking the LCM and then you multiply it here and there, so it is going to be a into x plus 2, 3x plus 1, then plus b into x minus 1, then 3x plus 1, then plus c into x minus 1, x plus 2. All right, so here you can solve for the values of a, b, and then c. So to get the value of a, in other words, we are eliminating b. So if you put 1, 1, if you put x as 1, it will give you the value of a. So if x is 1, this side you have 3 is equals to, this is 3, this is 4, so 12 a. So you're going to get your a as a quarter, because it will be 3 over 12, which is 1 over 4. If I need b, it means that here I will make it -2 and here -2, so that I eliminate a and c. So putting x as -2, this side it will keep 3 negative, I think, yeah, -3, because it will be -4 plus 1, which is -3, is equals to, the other ones have gone, so I have here -2 minus 1, that is -3 minus 6 plus 1. It will give you, wait, -3 is going to be C. I'm on B, right? It's going to be 15. It's going to be 15 because this is -2 minus 1, that is -3. -6 plus 1, -5. Multiply, you get 15. Trying that my B is that's -3 over 15, which is the one of -5, -50. Then if I need the value of C, if I need C to eliminate these ones, I will put 1. To get C, I'll put X as a third. To get the value of C, because yeah, you put x as negative a third by inspection. Otherwise, you can expand and then factorize. So this side will have a third, because it will be -2 out of 3 plus 1, which is a third. It's going to be equal to this side. When you put a third, you're going to get -20 out of 9c. Then you solve for c, get -3 out of 20. Meaning that our partial fractions are 2x plus 1 over x minus 1 then times x squared plus 7x plus 2. It's going to be equal to a. My a is a quarter, so it is going to be 1 over 4 into x minus 1 plus b in our b. The value of b was -1 over 5, so it's going to be -1 over 5 into x plus 2, then plus the value of c, -3 out of 20 into 3x plus 1. Now, when you're integrating, you integrate 1 by 1. Of course, you will be factorizing a quarter, a fifth, and -3 over 20. Others will become ln x minus 1, ln x plus 2, ln 3x plus 1. So I want everyone to complete that. I really want everyone to complete that. And then I see how best you people can do it. But I really want everyone to complete that. Anyway, let's integrate together. 2x plus 1 over x minus 1, x squared plus 7x plus 2 dx is going to be equal to the integral. Let me put my quarter outside. So 1 over x minus 1 dx plus, I can pull out -1 over 5 integral 1 over x plus 2 dx. Then still here I can put out 3 over 20 integral 1 over 3x plus 1 dx. This is going to give you a quarter ln x minus 1 minus 1 over 5 ln x plus 2. Then this one would be, of course, -1 over 20 ln 3x plus 1, right? Yeah. So, of course, plus a constant of integration since we don't have limits. So here I can factor out 1 over 20. Remember, when you put out 1 over 20, this is going to become ln, of course, here it is going to be 5. Here it will be 5 because quarter is already out. So here you put 5. If I put here 20 to bring out the aspect of a 4, I'll put 5 here. So that becomes 1 over 4. So it will be x minus 1 to the power 5. Okay. To the power 5. Then these are negatives. So anyway, let me first say minus 1 over 5 ln x plus 2 minus 1 over 20 then 3x plus 1. 20 is already out, eh? So since 20 is already out, this one will be a quarter. And here I will have nothing. then plus c. So this is the same as 1 over 20 ln. This is the only thing that is positive, so x minus 1 to the power 5 out of, since this is negative, it will be x plus 2 power 4. It's going to be x plus 2 power 4. It's going to move down simply because you're subtracting, meaning you divide. Then also this one is subtraction, so it will be 3x plus 1. And that is as simple as that. Then that question 4, where we have, actually it is part D, but I really want all of us to try it out. We have x squared minus x plus 1 over x squared minus 1, x plus 2. This is very easy in a way that you have to first work on this. You have to first work on this, whereby this one is the same as x minus 1, x plus 1. This one only, because it's a difference of 2 squares. Then you join it to this, and you continue as we've been doing. I'm doing the last part, which I'm given limits. I'm given limits of that part. And allow me do it. It's integral from 1 to 3 of x squared plus 1 over x cubed plus 4x squared plus 3x dx. This is the same as the integral from 1 to 3 of x squared plus 1 over, factorize out x. So that you have x squared plus 4x plus 3 dx. I've just moved out one x, a single x here. So this is the same as, of course, this one now is a quadratic equation, a rather expression which can easily be factorized. So this is going to be equals to integral from 1 to 3 of x plus 1 out of x into, when we factorize out this, we are looking at those factors which when added you get 3 and which when multiplied, rather when multiplied you get 3 and when added you get 1, that is 3 and 1. So if these are the factors, then it means that you will have x plus 1 and then x plus 3. Give it time, factorize. It's going to be x squared plus 3x plus x plus 3. You factorize, you'll have x into x plus 3 plus 1 into x plus 3. So the factors are x plus 1 and x plus 3. So that is what we are integrating. But first work it out without limits and first get a partial fraction. So we shall let x plus 1 over x into x plus 1 times x plus 3 to be equal to a over x plus b over x plus 1 then plus c over x plus 3. Of course, we shall solve. We shall have x plus 1 is equals to a x plus 1 x plus 3 plus b into x plus 3 then x, then plus c into x plus 1 then x. So looking at this, if I need a value of a, by putting as 0, as x as 0, putting x equals to 0, this side is going to be 1 is equals to 3a. giving me A as my third. And if I want value of B, if I want B only, so I will put X as -1. So that all of this is eliminated and this all is eliminated. So if I put X as 1 this side, I'll be having 2 is equals to, this is 1 plus, this is 4X, 4B. And this one will give me my B as a, I had to put a -1. So that I have 2 as -2B. So this is gonna be equal to B -1. But if I need C, I'll just be putting X as -3. So that this side I have -2. Oh, here I have X squared. It's supposed to be X squared members, sorry. So if you put X as -3, it means that here you'll have -3 squared, which is 9 plus 1, that is 10. Ten is equals to -3 plus 1. That's -2 times -3. That is 6. So it is 6C. Solving, you get C as 10/6 is the same as 5/3. Having this, it means now that our partial fraction, X squared plus 1/x into X plus 1, then X plus 3 is equals to A, which is a third, so it is 1/3X, then plus B, which is -1 out of X plus 1, then plus C, which is 5/3 into X plus 3. Now, when you integrate X squared plus 1/x into X plus 1, then X plus 3 dx, it's going to be equal to the integral of a third X dx. Then minus, actually, let me go with the limits 1 to 3. 1 to 3 minus integral from 1 to 3 of 1/x plus 1 dx, then plus 5/3 integral from 1 to 3, 1/x plus 3. So this is the same as a third in X, right? That's the third in X, then minus, then X plus 1, then plus 5/3 in X plus 3, but everything from 1 up to 3. So what we do here, we substitute in the limits, which I begin with a 3, so it is going to be ln 3/3 minus ln we put here 3, it will be linear 4 plus 5 over 3 linear 6. That is the first case. Then we subtract when we substitute in the lower limit. It's going to be linear 1 over 3 minus ln, when we put here 1, it will be linear 2, then plus 5 over 3 ln, when you put here 1, it will be linear 4. So work it out, pull on the calculator, and to come to 0.3488 as the answer. So there is it all about integration of involving linear factors. And all I wish you is to join me in the next video where I'm looking at the repeated factors, where we have repeated factors, after which we shall look at integration of improper fractions. So let's join in the other video. God bless you.